As our world continues to change, one thing remains constant. Geological map is a critical tool that you must have. Flooding, earthquakes, volcanic eruptions, uh, heavy rainfall, snowfall, even military warfare. All of these events come into contact with the earth and the earth in and of itself in terms of where the materials are, in terms of what's the condition of the materials, the amount of the material that is there, where the nearby water systems are, where the nearby discontinuities slash fractures are. All of this is revealed in a geological map. Now, the essence of this video is to just bring to your attention some basic things you should be aware of where it comes to you knowing the geological map. So take a look at this map. This section of this map highlights Stony Hill. Specifically, you can see big dash lines and you can see relatively smaller dash lines. The big dash lines, we consider these as inferred faults. Smaller dash lines, contact between two different lithologies. The different colors just is a representation of the difference in the actual lithology itself, or the nature of the rocks or the nature of the soils. Now you can see the T, small t, that is a representation of what we call dip and strike. In other words, where is the rocks aligning themselves in terms of their dip, and where is also the strike in terms of the perpendicular alignment to the north, azimuth north, that is. Now, the dip amount, we can see this in terms of these numbers. So when you can see the 70 or the 90 is indicating the degree of inclination of the rock strata. Now, in terms of slope, this has some close resemblance to the slope inclination, but it is not necessarily the same. Now, this is not a highlight of what it is that the lithology can look like in the field. And when we come across the lithology, we will note it in our notebook, and then we'll go forward and represent it on the map. This is a highlight of just a gentle dip, and this is another example of a different lithology with a much more sharper dip angle. You can also see that this rock strata is relatively fractured, highly fractured, that is. So essentially, getting all of this data from the field is what it is that we use to represent it on the map. So this map, 2D, is a representation of the world that we see in 3D and even 4D. There are those maps that can also be 3D, and these maps are more so those that we can make in GIS as an example. But if you don't have access to those maps, nevertheless, the 2D map is your go-to where it comes to having that insight of the nature of the land that you have interest in erecting whatever kind of property, or as regards any specifics for the construction project. So if it's a case that we're talking about being construction safe, it's about ensuring that we use the data, or rather, before we even use the data, we go forward with collecting the best possible data, right, in a much relevant timeline period, that is saying, and at a scale that is relevant to the project itself. And then now, based on that data collection, we move forward into interpreting it, right, and to go forward with the best practice based on the data that is there, so that where it comes to the project itself, the project can have the best chance of being in a safe, constructed manner, right? This is where the geological map as that tool comes in. And this is where you having this insight goes a far way in helping to build that culture, to build that society that has a much more resilient nature in its construction, in its infrastructure, in these changing times. Now, this is a copy of a finished geological map compared to the one I showed earlier. That one is more so the rough version. This now would have been done in ArcGIS. And this map, you can see the title, you can see the north arrow, You can see the scale, you can see the legend with an outline of the lithology, the color code, and the map of Jamaica, which is what we call an inset map. Now, essentially, this map, in terms of the highlight of the lithology, you can see it says soft, chalky. Those kind of terminologies are more so aligned with the engineering interests. So this geological map is specific for engineering. There can be different maps for different purposes. There could be those water or hydrogeologic maps that have a much more focus on underground water or aquifers. There could be those geological maps that are more so mineral focused. And there could also be those geological maps that are just more so focused on hazards. So it all comes back down to what is the data you want to be revealed specific to the project that you have an interest in. But nevertheless, all of these are what can be highlighted in a geological map. And when it comes to you going forward and accessing a geological map, these are the things that you should be paying attention to.